Okay, Bismillah ar-Rahman ar-Rahim. Now we'll speak about matrix, exponential, and linear system. First of all, we are going to define initial value problem, which is the same homogeneous system we have linear system, but x at 0 equal to x naught is the initial value. Then the solution of the initial value system will be phi of t, which is we will call it uh, fundamental function times the inverse of the fundamental function at 0 times x naught. What is the definition of the fundamental theorem? If I have eigenvalues and corresponding eigenvectors, so the fundamental will be the eigenvalue times the exponential e to the power lambda 1, the second eigenvector times e to the power lambda 2, and so on. Okay, of course, we remind ourselves about finding an inverse of a 2 by 2 matrix 1 over delta. We are switching the main diagonals and changing the sign, so that will be the determinant in another word. That's the determinant of A. Okay, we call it sometimes delta. This is another one to find an inverse of a 3 by 3, although I'll focus only in 2 by 2 here. Now, find the fundamental matrix of this system. So we will say step 1, find the eigen values and corresponding eigen vectors. So I'll say here of the matrix 4, 2, 3, minus 1. So we will say it's 4 minus lambda, 2, 3, and minus 1 minus lambda equal to 0. So it will be 4 minus lambda minus 1 minus lambda minus 6 equal to 0. So it will be minus 4 minus 4 4 times minus 1 minus 4 times or minus lambda will be minus 4 lambda plus lambda plus lambda squared plus minus 6 equal to 0. So we will have lambda squared minus 3 lambda minus 10 equal to 0. We had this one before, it's minus 5 and times plus 2. So either lambda 1 is minus 2 or lambda 2, which is equal to 5. Then we said we solve for eigenvectors and we put here minus 2, so we will get 6, 2, 0, and that will be 3. Minus of minus 2 will be plus 2, so that will be 1, 0. And we said if we divide by 6, you get 1, 1/3, 0, and that is 3, 1, 0. Then we said using our echelon form, it will be minus 3 row 1 plus row 2, and we will get 0, 0, 0. So our k1 plus a third of k2 is 0, so k1 is minus 1/3 k2. So choosing k2 to be minus 3, k1 will be 1. So our eigenvector will become 1 and minus 3. That's the first one. For the second one, we have for lambda 2, our lambda 2 it's 5. So we solve, we put 5, so it will be 4 minus 5 is minus 1. 2 on the right hand side 0, that is a 3. Minus 1 minus 5 is minus 6. You can see now that will be 1 minus 2, 0. And if we say multiply 1 by 3, which is, I mean this one, if I multiply it by 3 plus row 2, so that will be 0, 0. Okay, so I will get k1 minus 2k2 is equal to 0. So K1 it's 2 times K2, so choose K2 to be 1, K1 will be 2, and our eigenvector it's 1, 2, and 1. So what does that mean? It means our fundamental matrix phi of t is defined to be the eigenvalue, which is, the eigenvector, which is 1 and minus 3, times e to the power lambda 1. Lambda 1 is minus 2, so it will be here the entry, it's 1 e raised to the power lambda 1, which is minus t, and that will be minus 3 e raised to the power minus 2t. Okay, that is what we have. What we said here, it's v1 times e to the power lambda 1. So e to the power lambda 1, our lambda is minus 2 times v1, which is this one. So it will be e raised to the power minus 2t times 1 and e raised to the power minus 2t times minus 3. Same thing for the second one. It will be 2 e to the power lambda 2, which is 5t, and that will be the entry 1, so it will be e to the power 5t. So the first one comes from e raised to the power minus 2t times its vector, which is 1 minus 3. That's the first column. The second column will come from e to the power 5t times its vector, which we call it 2 and 1. That's what is the form of the fundamental matrix. Now, what is phi at 0? Phi at 0 will be, when I substitute 0, I'll get 1, 2, minus 3, and 1. What's the inverse at 0? It will be 1 over the determinant. The determinant, it will be 1 times 1 is 1 minus of minus 6. And then we will swap 1 and 1, it will be the same. We change the sign of that one, so that will be minus 2 and 3. So what I will get? I will get 1 over 7 minus 2 over 7, 3 over 7. Okay, and 1 over 7. So what will be the solution of the initial value problem now? When I get that one, I get the fundamental, I get v at 0 and v inverse. Now our next question will be how to find the solution of that one. So we have x at 0 is equal to 1 and minus 1. And we have calculated v at 0. We said it is v at 0, it was, sorry, we need v of phi at t. We said it is equal to e raised to the power minus 2t, and what we have done, okay, minus 3 e raised to the power minus 2t, and we have 2e to the power 5t and e to the power 5t. Okay, that's phi of t. So what is our solution according to what we have in the theorem? Since we have the inverse at 0 is equal to 1 over 7, it was 1 over 7, 1 minus 2, 3, and 1. So that's 1 over 7, 1 minus 2, 3, and 1. Okay, so we will say according to the solution of according to the theorem, it will be x of t is equal to phi at t, which is the fundamental matrix, times the inverse at 0 times x at 0. So what we will have, we will have 1 over 7 is the constant number which comes from here actually, times the fundamental, which is e raised to the power minus 2t, 2e to the power 5t, minus 3e to the power minus 2t, and e to the power 5t, times 1 minus 2, 3 and 1, times x naught, which is given to be 1 and minus 1. When we multiply this one, we will get now first row, let me say, I'll leave 1 over 7 for the end. I will have the first row, which is minus 2t, 2e to the power 5t, multiplied with the first column, which is 1 and 3. So what I will get, e raised to the power minus 2t plus 6e to the power 5t. Okay, that will be, this is equal to 1 over 7 as it is. The first entry will be e raised to the power minus 2t plus 6e to the power 5t. Okay, then the first row times the second column. Second column will be 2e to the power 5t and e to the power 5t. Sorry, I have done a mistake here. I said first, oh no, it's okay, times, here is a mistake. First times the second, which is minus 2 and 1. That's okay. Now that will be minus 2 e to the power minus 2t plus 2 e to the power 5t. So that will be minus 2 e raised to the power minus 2t plus 2 e to the power 5t. Okay. Same thing we do with the second row. We'll say second row, which is minus 3 e raised to the power minus 2t and e to the power 5t, times the first, which is 1 and 3. So I will get minus 3 e raised to the power minus 2t plus 3 e to the power 5t. So that will be minus 3 e raised to the power minus 2t plus 3 e to the power 5t. And now times the second, second by second, second by second, which is minus 2 and 1. So that will be 6 e raised to the power minus 2t minus 2, minus e to the power 5t. So it will be 6 e raised to the power minus 2t minus e raised to the power 5t. Okay. Now, okay, so it will be second 6 plus 1, y plus 1. Yeah, it's minus 2 and 1, so that will be plus 1, yes. So that will be plus 1. Now, we multiplied the two matrices. We need to multiply it now by the element 1 and minus 1. So what we will get 1 over 7. When I multiply this one times that one, it will be, first row, which is e raised to the power minus 2t plus 6 e to the power 5t. The second entry, it's minus 2 e raised to the power minus 2t plus 2 e to the power 5t. When we multiply it with 1 and minus 1, we will get e raised to the power minus 2t plus 6 e to the power 5t plus 2 e raised to the power minus 2t minus 2 e raised to the power 5t. So that will be equal to 3 e raised to the power minus 2t, and 6 minus 2, it's 4 e raised to the power 5t. Okay, so I will get here, it's 3 e raised to the power minus 2t plus 4 e raised to the power 5t. Same thing, second row. Now the second row we have times the first column. So the second row I have minus 3 e raised to the power minus 2t plus 3 e to the power 5t. We'd like to multiply it with 6 e raised to the power minus 2t plus e raised to the power minus 5t. Oh, sorry, plus 5t. So I'll get minus 3 e raised to the power minus 2t plus 3 e to the power 5t minus 6 e raised to the power minus 2t minus e to the power 5t. So I will have here minus 9 e raised to the power minus 2t. 3 minus 1 is 2 e to the power 5t. So I will get here minus 9 e raised to the power minus 2t and I have a plus 2 e to the power 5t. That will be the solution of the initial value problem. Now we are going to the second idea, which is the exponential. If we have, that is, of course, this means r, and let's say, we know the exponential e to the power z, it will be 1 plus z squared over 2 factorial, and so on. That is in the exponentials, which we can write it as a summation a to the power n over n factorial. We will use this idea in order to find a to the power n. Okay, so if I have a diagonal matrix, what is a squared, which is a times a, it will be actually a 0 0 b. When you multiply it by itself, a 0 0 b, you will get actually, first I'll just show you a0, so I will get a squared. First row, which is a0 times the second one, which is 0b, it will be 0. So I'll get here a squared and 0, and here it will be 0 and b squared. By the same story, taking the second row, multiply it with the first, you will get 0. Taking the second row, multiply it by the second, so you will get only b times b, which is b squared. Now, of course, when I multiply now a cubed, what I will expect, I will expect a cubed 0 0 b cubed, and so on. A to the power 4, it will be a to the power 4 0 0 b to the power 4. So if I say a to the power n, it will be a to the power n 0 0 b to the power n. Now, if I want to find e to the power a, according to our rule, e to the power a, it's the identity matrix, then the matrix a, then the matrix squared over 2 factorial, and so on, cubed over 3 factorial, and so on, until a n over n factorial, which means I will have 1 0 0 1. Then I will have here a 0 0 b. Then I will have here a squared over 2 factorial, okay, 0, and then 0 b squared over 2 factorial. And we will end up with a n over n factorial, 0, 0, and bn over n factorial. So that is actually equal to what? That will be 1 a plus a plus a to the power n over n factorial. Then 0, that will be 0, and here you will have 1 plus b squared over 2 factorial until bn over n factorial, which is actually equal to e to the power a 0 0 e to the power b. That is what is e to the power a. Now, for a diagonal matrix, we define what is a diagonal matrix in the eigenvalues. So e to the power d, which will be just e to the power, the first eigenvalue, and e to the power n. So now we will use our idea of I have e to the power a plus b, it's e to the power a times e to the power b. If we have ab is equal to ba here, then again e to the power a to the power minus 1 will be e to the minus a, and we will have e to the power at, it's simply a to the power n tn over n factorial. That is the main theorem. Now, if I have here a and b are matrices, we want to show a is nilpotent. What is nilpotent? Nilpotent simply is a matrix when you square it or cube it. After some times, you will get a to the power n is equal to 0. So if we say, for example, a, what I have a is 0, 3, 4, 0, 0, 6, 0, 0, 0. When I find a squared, which means a times a, that is 0, 3, 4, 0, 0, 6, 0, 0, 0. When I multiply it by itself, which is 0, 3, 4, 0, 0, 6, and 0, 0, 0, what I will get? First row, which is 0, 3, 4, times first column, it will be 0. Now, first row by second column, which is a 3, 0, 0, again I'll get 0. First row, third column, which is 4, 6, 0, I will get 18. Okay? Now, and we finish from the first row. Second row, we have double 0, 6. If I multiply it with whole, that will be 0. If I multiply it with the second, which is 3, 0, 0, again I'll get 0. If I multiply with the third, which is 4, 6, 0, I will get again 0. And of course, when I multiply the third, all of them will be 0 because the entire row is 0. Now this is a squared. Still, we did not reach it is equal to 0. So what is a cubed? A cubed means a squared, or a times a squared. It will be a times a squared. Since we have a is equal to 0, 3, 4, 0, 0, 6, and 0, 0, 0, I multiply it with a squared, which is 0, 0, 18, 0, 0, 0, and here we have 0, 0, 0. Again, when I take the first row, which is 0, 3, 4, if I multiply it with 0, 0, 0, I'll get whole 0. And if I multiply it with the second column, which is again 0, so that will be 0, with the third, which is 18, 0, 0, and I'll get 0. So of course the rest will be 0. So we can say now, since a to the power 3 is equal to 0, that will mean a to the power 4 is a to the power 4, 8, that will mean a to the power 4 equals to a to the power 5 equals to a to the power 6, all of them a to the power n, all of them will be 0, and because we have a to the power 3, which is 0. So all of them will be 0 because a to the power 4 will be a cubed times a. That's what is meant by nilpotent. Now, find e to the power 80. What's our theorem to find e to the power 80? We said e to the power 80 means uh, summation e to the power 80. It's the sum of a to the power n, e to the power uh, a to the t raised to the power n. It will be t to the power n over n factorial. That is e to the power 80. Okay, so e to the power 80, it will be a to the power n t raised to the power n, which is equal to, first, when n is equal to 0, from n0 to infinity, when n0, I will get identity matrix, then a times t, then a squared, t squared over 2 factorial, and so on, a cubed, t cubed over 3 factorial, and so on. But we know a cubed is 0, so all the rest will be 0. So what I will have, I, which is 1001, plus a, which is 034006000, times t, plus a squared, which we get a squared, it's the only one entry 18, which is 0018, and the rest are zeros, and it will be multiplied with t squared over 2 factorial. Okay, so what I will get, I'll get the matrix 1 plus here 0, so this is just 1. The second entry, sorry, I have the identity matrix, it's 1 0 0 0 1 0 0 0 1. So I will have here the second entry will be 0 plus 3 times t, and that will be 0. The fourth entry, that is 0 plus 40, okay, plus 18 t squared over 2 factorial. Okay, here I will have 0 and 0, all of them 0, and here I will have 1, then I have 0 here and 0 there. I will have the third here 0, 60, and that is 0, so that's finished. So here I will have all zeros. That's what we will have as a matrix. Here it will be, sorry, 1. Okay, so that is the exponential e to the power 80. That's the only idea we have today. It says use part 1 to find e to the power bt. Now, which means actually we will uh, use actually part 2, not part 1. Which means actually we would like to write b, which is equal to 2 3 4 0 0 6, and here 0 0 0. We will write it as, sorry, that is not uh, that's not b. B, it's 2 3 4 0 2 6 and 0 0 2. We will rewrite it as uh, the matrix, to diagonal matrix, which is 2 0 0 0 2 0 0 0 2. That's the diagonal matrix, plus a, which is a will be 0 3 plus a, which will be 0 3 4 and 0 0 6 0 0 0. If we add these, you will get that one. So this means e to the power b, it will be e to the power d, which is the diagonal matrix, plus e to the power b. Okay, so that will be equal to, of course, d. If we say t here, it will be t there and t there. So what I will get, e to the power dt it will be e to the power 2t 0 0, and that is 0 e to the power 2t 0 0 0 e to the power 2t. That's our theorem. Plus e to the power here, sorry, that's a. E to the power 80, we found it in the previous step, which was 1, then 3t, then 4t plus 9t squared, and that is 0, 1, 60, and that will be 0, 0, 1. So when we add these, we will get e to the power 2t, it's 3t, okay, e to the power, uh, wait a minute, I have done a mistake here. It's not plus. This is not a plus, that's multiplication. It's e to the power dt times e to the power 80. That will be what is e to the power d plus a, that's d, that's a, times t. So what we have, e to the power dt will be, this is equal to e to the power dt, e to the power 2t 0, 0, 0 e to the power 2t 0, and 0, 0 e to the power 2t, multiplied with e to the power 80, which we have 1, 3t, and 4t plus 9t squared, and we have also 0, 1, 60, and we have 0, 0, 1. When we multiply these two matrices, what we will get? We will get the first row times the second column, it will be e to the power 2t. First row times the second column, it will be 3t e to the power 2t. And the first row times the third column will be 4t e to the power 2t plus 9t squared e to the power 2t, and so on. We will get here second row times first column is 0. First times second, it will be e to the power 2t. Okay. Second by third, that is 0. That will be 6t, and third now row by first column will be 0. Third row by first column again, it will be 0, and the third row first column, it will be e to the power 2t. So we are using the idea, if I have e to the power a plus b, that is actually e to the power a times e to the power b. That's the main idea which we are using. Now, that's the whole thing in this section. Now I'm just repeating similar questions of what we have done previously. There is no new idea after example number 4. So what I have here, we need to compute e to the power 80. What is our first step? We had in example number 1 the fundamental matrix phi of t, which we get e raised to the power minus 2t and 2 e to the power 5t. And I have minus 3 e raised to the power minus 2t, and that's e to the power 5t. So we find what is phi at 0 also, and we get 1, 2, minus 3, and 1. And also we found the inverse at 0, which is 1 over 7. We said we change the position, but they are the same. We change the sign here. Okay. Then we said, okay. Now, what is the rule we have here in this slide? We said e to the power 80, that's the only idea we have. E to the power 80, it will be phi of t times phi inverse. Okay, so mm, okay. Mm, so that will be, according to our theorem, we will have e to the power, the rule we are going to use, e to the power 80 is equal to uh, phi of t times the inverse at 0. So that will be equal to phi of t, which is e raised to the power minus 2t, 2e to the power 5t, minus 3 e raised to the power minus 2t e to the power 5t, times the inverse. So I'll put 1 over 7 here, which is 1 minus 2, 3, and 1. Now, when we multiply this one, we will get e raised to the power minus 2t plus 6 e to the power 5t, then minus 2 e raised to the power minus 2t plus 2 e to the power 5t, and that will be minus 3 e raised to the power minus 2t plus 3 e to the power 5t, and that will be 6 e raised to the power minus 2t plus e to the power 5t. Just we multiply these two matrices. Now, now here it says use exponential matrix to find uh, the solution of the initial value problem. Okay, so what we will do, we will find first the the eigenvalues. So we will say we are going to solve a minus lambda I equal to 0. It will be 2 minus lambda 3, 4, 0, 2 minus lambda 6, and that is 0, 0, 2 minus lambda. If we expand it over the first column, it will be 2 minus lambda times the minor, and the minor will be 2 minus lambda 6, 0, 2 minus lambda, and that will be 2 minus lambda. We'll expand this one, it will be 2 minus lambda all squared minus 0. So it will be 2 minus lambda all to the power 3 equal to 0, which means lambda 1 is equal to lambda 2 is equal to lambda 3, which is equal to 2. If we solve for eigenvector, which means we replace lambda by 2, we will get 0, 3, 4. Here it will be 0, 0, 6, and that will be 0, 0, 0. So I will get here K3 is equal to 0, and I will have 3 uh, K2 plus 4 K3 is 0, which means K2 is equal to 0. So I will have only one eigenvector, which is K is 1, 0, 0, because K1 is a free entry. Okay, I have only one eigenvector. So what I will say now, what will be my fundamental matrix? The fundamental matrix we will have um, now. Uh, okay. Wait a minute. If I have only one, so I will have here e to the power. Use its crucial initial variable. You can ignore this one because we are not interested in repeated eigenvalues. Let's go to, now we are repeating the same story. That is cancelled. That's not, we are not interested in that one. Okay. Now, we repeat the same story now. What's first the fundamental matrix? We need to solve A minus lambda I to get the eigenvalues. So it will be 2 minus lambda 1, 1 and 2 minus lambda. So it will be 2 minus lambda all squared minus 1. So we can say 2 minus lambda minus 1 times 2 minus lambda plus 1, which is difference of two squares. So that will be 2 minus 1 is 1 minus lambda, and here it will be 2 plus 1 is a 3 minus lambda. So that will be equal to lambda 1 is equal to 1, lambda 2 is equal to 3. So we need to solve for eigenvectors. So we will say 2 minus 1 is 1, 1 here, 1 and 1. So we have actually one equation which is k1 plus k2 equal to 0. So k1 is negative k2. So our k will be, k2 is minus 1, k1 will be 1. For the second eigenvector, we have for lambda 2, which is equal to 3, it will be uh, 2 minus 3 is minus 1, and 1, that's 1, and that's 2 minus 3 is minus 1, is 0. So we said here that's only one equation because when I swap, this is 1 minus 1, 0, and minus 1, 1, 0. If I add, now that's leading. If I add row 1 plus row 2, you will get 0, 0 equal to 0, which means k1 minus k2 is 0. So k1 is equal to k2, and the eigenvector will be 1 and 1. Once we get uh, once we get the eigenvectors, we can define our fundamental function to be e to the power the first one e to the power t times the eigenvector, so it will be e to the power t and minus e raised to the power t. And the second one here, it will be e to the power 3t times 1 and e to the power 3t times 1. Okay, so that is the fundamental matrix. Okay, now we need to find what is phi at 0, and phi at 0 means 1, 1, minus 1, and 1. And we need to find also the inverse at 0. The inverse at 0, we said we swap these two, but they are the same. We change the sign here, minus, and that will be plus. Okay, divided by the determinant, which is 1 minus of minus 1, which is plus 1. So that will be 1 half, 1 minus 1, 1 and 1. Okay, now, therefore, we have now our solution x of t, which is defined to be phi of t times the inverse at 0 and times, I mean, that is the next step to solve the initial value problem. So the initial value problem solution will be, we said it is phi of t times the inverse at 0 times x naught. So that will be phi of t, which is e to the power t, e to the power 3t, e to the power t, and e to the power 3t. Then I have minus e raised to the power t and e to the power 3t. Okay, that's what we have. Times the inverse, and the inverse was half. Inverse at 0, it's half, 1 minus 1, 1 minus 1, 1 and 1, times x naught, which is 3 minus 2. So when we multiply this one, first row e to the power t, e to the power 3t, times first column, which is 1 and 1, we will get e to the power t plus e to the power 3t. Now first row by second column, it will be e to the power t minus e to the power t plus e to the power 3t. That is first row, second column. Now finish from that one. Now we take the second row, which is minus e to the power t and e to the power 3t. We multiply it with the first, so it will be minus e raised to the power t plus e to the power 3t. Now, if we multiply it with the second one, it will be minus 1 and 1, so it will be e to the power t plus e to the power 3t. We need to multiply it with the 3 minus 2 now. So what we will get, that will be 1 half. It will be 3 e to the power t plus 3 e to the power 3t, and minus times minus will be plus 2 e to the power t minus 2 e raised to the power 3t. And here I will have minus 3 e to the power t plus 3 e to the power 3t minus 2 e to the power t and minus 2 e raised to the power 3t. That is the multiplication. So we can simplify this one to say I have here 3 plus 2, it's 5 e to the power t, and 3 minus 2, it's 1 e to the power 3t. Okay, And here we have 3 minus 3 minus 2x minus 5 e to the power t, and here we have 3 minus 2x1 e to the power 3t. That will be the solution of the fundamental theorem. Okay, now I hope this is not repeated, so let's do it for a 3 by 3. Okay, for 3 by 3, let's hope this is not a repeated one. So I will find, do I have space here? Okay. Okay, so I will find first a minus lambda I, which is the eigen value. So that will be 5 minus lambda 0 minus 6, that is 2 minus 1 minus lambda and minus 2. 4 minus 2 minus 4 minus lambda equal to 0. Now, that will be 5 minus lambda times the minor, which is minus 1 minus lambda minus 2, and that will be, is this, minus 2 minus 4 minus lambda. Then minus 0 to go, plus minus 6, and the minor of minus 6, it will be 2 minus 1 minus lambda 4 and minus 2 equal to 0. Now, so I will have here 5 minus lambda, and it will be minus 1 minus lambda times minus 4 minus lambda minus 4, that's minus 6, that will be minus 4, minus of minus will be plus 4 times 1 plus lambda. Now, when we expand this one, we will have 5 minus lambda. Here I have minus times minus 4 is a plus 4, minus times minus lambda is plus lambda, plus 4 lambda, plus lambda squared minus 4. I have here minus 6, minus 4 plus 4 plus 4 lambda. Now that will be nice because plus 4 minus 4 is 0, so I'll have 5 minus lambda times. Here I have lambda squared plus 5 lambda, which is great. I have here minus 6, again minus 4 plus 4, so I will have 4 times minus 6 is minus 24 lambda. Now it's clear lambda is a common factor, so I will have here 5 minus lambda, and I will have lambda plus 5 minus 24. So that will be lambda times, that is 5 minus lambda times 5 plus lambda will be 5 squared, which is 25 minus lambda squared minus 24 equal to 0. So I'll have lambda times 25 minus 24 is 1 minus lambda squared. So our lambda is equal to 0, or lambda is equal to 1, or lambda 3, which is equal to minus 1. So I have different eigen values. So for each I will have eigen vector. So I will say for lambda 1, which is equal to 0, we will solve, we will replace now here by 0. We will get 5, 0 minus 6 equal to 0. That's 2 minus 1 minus 2, 0. That's 4 minus 2 minus 4, 0. Now, so we will use eigenvalue, the echelon form. We'll divide row 2 by 1. We'll get 1 minus half and minus 1 equal to 0. So that's half row 2. I made it row 1. And that is 5, 0, minus 6, 0, 4, minus 2, minus 4, 0. So that will be 1 minus half minus 1, 0. So let's say minus 5 row 1 plus row 2 minus 5, 5 over 2. We multiply by minus 5, so that will be 5, 0. We will add it with 5, 0, minus 6, 0. So that will be 0, 5 over 2 minus 1, 0. So I'll get here 0, 5 over 2 minus 1 and 0. And I need here minus for row 1 plus row 3. So if we multiply by minus 4, that will be 2, that will be 4, that is 0. We add it with that one, the entire row becomes 0, which is great. Now I can find a bifoot or leading term. Multiply by 2 over 5, I'll get 0. If I multiply by 2 over 5, I'll get 1. If I multiply by 2 over 5, that will be minus 2 over 5, 0, and that's entirely 0. Now the last step is, oops. Now what we will say now, half row 2 plus row 1. What is half row 2? It will be 0, half minus 1 over 5, 0. We add it with 1 minus 1 half minus 1, 0. So I'll get here 1, 0. That will be minus 6 over 5 and 0. So that will be 1, 0, minus 6 over 5, and the right hand side 0. That will be 0, 1. Uh, so we said 1, 0, minus 6 over 5, and the right hand 0. That will be minus 2 over 5 and 0. Now, and here the entire row is 0. We can stop here because K1 is equal to 6 over 5 K3. So we choose K3 to be 5. Okay, and here we have K2 is equal to 2 over 5 K3. So what we will get, the eigenvector, K3 is 5, K2 will become 2, K1 will be 6. So I have 6, 2, 5. Now, for the second one now. For the second one, I will have for lambda 2, which is equal to 1, we will solve 5 minus 1, which is 4, 0 minus 6, and that will be 0. It will be 2. We said our lambda is 1, so that will be 1 minus 1 is minus 2, minus 2 and 0, and that's 4 minus 2 and minus 4, minus 1 is minus 5 is 0. It's clear now. If I divide row 2 by 2 and make it 1, it will be 1 minus 1 minus 1. That's the easiest one. So that is 1 half. Row 2 becomes row 1, and row 1 becomes row 2. That's 4 minus 2 minus 5, 0. So we'll use it to make the elements below 0. We will say that's our leader. and here we have minus 4 row 1 plus row 2. Minus 4, 4, we multiply by minus 4. So that will be 4 and 0. We add it with 4, 0, minus 6, 0. We get here 0, 4, minus 2, 0. So 0, 4, minus 2, 0. We add the same thing here, minus 4, row 1 plus row 3, which is 4 minus 2 minus 5, 0. We'll get here 0. We have here 2 minus 1, 0. 0, 2, minus 1, 0. Now we can say we can prepare another bifoot, divide by 4 the second row. You will get 0, 1, minus half, 0, and that is 0, 2, minus 1, 0. Now if I add row 1 and row 2, because 2 cancel out, minus 1, so that will be 1, minus 1 plus 1, 0. That will be minus 3 over 2. We are just adding minus 1.5, and that's 0. That's our leading. If I multiply by minus 2, row 2 plus row 3, so it will be 0, minus 2 plus 2, 0, minus 2, it will be 1, minus 1, 0, so the whole row becomes 0. This means K1 is equal to 3 over 2 K3, and K2 is half K3, so our eigenvector, when we choose K3 to be 2, our K will be, that's 2, K1 will be 3, K2 will be 1. Same story, we'll do it for lambda 3, which is minus 1. We will solve, we put minus 1, we will get 6, 0, minus 6. If we put minus 1, we'll get here 2, 0, minus 2. If I put minus 2, that will be minus 4 plus 1, which is minus 3. Now, again, we can say divide by 2 row 2 and make it 1, so it will be 1, 0, minus 1, 0. This is 6, 0, minus 6, 0. That's 4 minus 2 minus 3, 0. So we say 1, 0, minus 1, 0, multiply by minus 6 plus 0. That will be 0, minus 6, it will be plus 6, that will be whole 0. If we multiply by minus 4, that will be 0, and that will be 0. 4 minus 3, it's 1 and 0. So this means we have K3 is 0, which means K1 will be 0, and K2 is a 3. So our eigenvector will be K1 0, K3 0, K2 is 1. That's the eigenvector. Okay, so let me just write down these to move to the other one. So currently we have the following. We have the first eigenvalue is lambda 1, which is 0, and its corresponding eigenvector becomes 6, 2, 5. We have lambda 2 is equal to, we call it 1, and the corresponding is 3, 1, 2. And lambda 3 is minus 1, and 0, 1, 0 is the eigenvector. So what is the next step? Is to find the solution of that one. Okay, I need to use the funny matrix. So the fundamental matrix phi of t is equal to phi of t, we said it will be defined e to the power 0 times t times e to the power 0 t. It will be same 1, so it will be 6 to 5. And the second one, e to the power t times its eigenvector, so it will be 3 e to the power t, e to the power t, and 2 e to the power t. and the third one e raised to the power minus 3t, so that will be 0, e raised to the power minus t, and 0. That will be our fundamental matrix. Now, what is phi at 0? Phi at 0, it will be 6, 3, 0, 2, 1, 1, 5, 2, and 0. Okay, we have a definition, a rule for the inverse. You will apply it, which I mean is, instead of Gauss-Jordan elimination method, you can use this one. Okay, 1 over the determinant a11 minus a12. It's actually alternating. This is a plus minus a plus minus a plus minus a plus minus a plus, and here we have 1 1 1 2 1 3. That's okay. 2 1 2 2 2 3 3 1 3 2 and 3 3, where I guess that is the uh, minor. Okay, these are the cofactors, I guess. Anyway, if you want to find it out, find it, but it is a long procedure. We are not recommended. We are not recommending a long procedure for the final. This is just to show you how it looks like. The inverse will be, if you use Gauss-Jordan elimination method or that method, we will get, this is minus 4, okay, 0, 1. So let me make sure only, yes, it's the same. So that will be 11 minus 3 minus 2. That will be minus 1, 3, 0. So what will be our solution? Our solution will be x of t. It will be phi of t times the inverse at 0 times x naught. So that is 6, 3 e to the power t 0, 2 e to the power t e raised to the power minus t, 5, 2 e raised to the power t 0, multiplied with phi inverse, which is minus 4, 0, 1, 11 minus 3 and minus 2, and that will be minus 1, 3, 0 times 2, 1, 0. Okay, anyway, I'm not interested in a long question, so I'll just leave it for you. Now, how many? Anyway, the rest of the job, it's just repeating the same ideas. I'm not interested anyway. Let me, okay, let's continue. Let's, let's continue. It's okay. We'll repeat the same ideas only. So that will be first a minus lambda I equal to 0. So I will have 5 minus lambda minus 4, 3 minus 2 minus lambda equal to 0. 5 minus lambda times minus 2 minus lambda plus 12 equal to 0. So it will be minus 10 minus 5 lambda plus 2 lambda plus lambda squared plus 12 equal to 0. So I'll have lambda squared minus 3 lambda, and that will be plus 2 equal to 0. It's just repeating same idea again. So we have lambda 1 is 1, lambda 2 x2. We solve for I, when lambda 1 is 1, we'll get 4 minus 4, 0, 3, and that will be minus 2, minus 1 is minus 3. And you can see uh, that's when I substitute 1, it will be 4 minus 4, 3 minus 2 minus 1 is minus 3. Dividing the first one by 4, we use it. So when we multiply by minus 3 row 1 plus row 2, the whole row will be 0. So I'll get k1 is equal to k2, so the eigenvector will be 1 and 1. For lambda 2, which is equal to, in our case here, 2, we will get 3 minus 4, 0. That's 3 minus 4, 0. It's the same equation. So we have 3k1 minus 4k2 is equal to 0. 3k1 is equal to 4k2. So k1 is 4 over 3 k2. We divide by 3. So choose k2 to be 3. k1 will be 4. And the eigenvector will be 4 and 3. So what's our fundamental phi of t? The fundamental, it will be e to the power t times the eigenvector, so it will be e to the power t and e to the power t, e to the power 2t times the vector, which is 4 and 3. And we say phi at 0, it will be 1, 4, 1, 3. We say the inverse at 0, it will be 1 over determinant 3 minus 4, and swap and negative. So that will be 3 minus 4, it's minus 1, times 3 minus 4, minus 1 and 1. So phi inverse at 0 becomes minus 3, 4, 1, minus 1. That's our inverse. Okay? So I'll just write these down so that I don't go back and forth. So what I have, the fundamental matrix phi of t, it's e to the power t 4, e to the power 2t, e to the power t 3, e to the power 2t. The inverse at 0 is minus 3, 4, 1, minus 1. Okay. Okay, that's all. Anyway. Oh, even he's asking me to find the exponential. Okay, what's the exponential e to the power a? According to the theorem we have, is it e to the power a or e to the power 80? He's supposed to say e to the power 80, not a. Anyway, e to the power 80, it's phi of t times the inverse. It's e to the power 80, it's phi of t times the inverse at 0. Okay. So it will be using our theorem, which is e to the power, where is it? E to the power, this is correction here, it's e to the power 80. E to the power 80, the rule says it will be phi of t times the inverse. So it will be phi of t, which is e to the power t for e to the power 2t, and e to the power t 3 e to the power 2t. When we multiply it by the inverse, which is minus 3, 4, 1, minus 1, okay, we will end up with the matrix, which is minus 3 e to the power t plus 4 e to the power 2t. That's first times first, second times second. Same thing here, first times that will be 4 e to the power t minus 3 e to the power 2t. Okay, same story here. Again, that's a mistake, it's a to the power t. So we will find 3 minus lambda, 1, 1 and 3 minus lambda. So that will be 3 minus lambda all squared minus 1 squared equal to 0. 3 minus lambda all squared is equal to 1. 3 minus lambda is equal to plus or minus 1. So our lambda is 3 plus or minus 1. So either lambda 1 is 4, lambda 1 it's 2, lambda 2 it's 4. Now for lambda 1 we have when we substitute 2 you will get 1 1 and 1 when you substitute 2 1. So we have actually one equation which is k1 plus k2 is equal to 0. So k1 is negative k2. So our eigenvector will be, here is minus 1, here is 1. That's an easy one. Now for lambda 2 which is equal to 4, when we replace 4 it will be minus 1 1, 1 and 3 minus 4 is minus 1. So we can say 1 minus 1 0 as row 2 becomes row 1. And when I add row 2 plus row 1 we get the whole row 0. So we will have k1 is equal to k2. So our eigenvector will be 1 and 1. So this means we can define the fundamental matrix which is phi of t to be e to the power 2t times that one. So it will be e to the power 2t times 1 minus e raised to the power 2t, and the second one e to the power 4t times x vector e to the power 4t. Okay, what's this? What's e to the power 80? E to the power 80, it's phi of t times, we need the inverse first. So what's phi at 0? It will be 1 1 minus 1 1. So inverse at 0, it's 1 over determinant, which is 1 minus 1, which is 2. We swap these, we change the sign of that one. So our e to the power now 80, it becomes half e to the power 2t e to the power 40 minus e to the power 2t e to the power 40 times the inverse, which is 1 minus 1 1 1. When we multiply this one we will get first row by first column, it will be e to the power 2t plus e to the power 40. First row by second column, it will be minus e to the power 2t, okay, plus e to the power 40. Okay. Let me just check this is the same. This is example 4. Okay. Yeah, that's right. And then that will be minus e to the power 2t plus e to the power 40, and that will be second row by second column, it will be e to the power 2t plus e to the power 40. That's all. Now he wants me to show a is nilpotent, which means I need to multiply first a by a to get a squared. It will be a, which is 1 minus 1 minus 1, 1 minus 1 1, 0 0 0. When I multiply it by itself, which is 1 minus 1 minus 1, 1 minus 1 1, 0 0 0. So what I will get, first row 1 minus 1 minus 1 by first column, which is 1 1 0. I'll get 1 minus 1, which is 0. Then by second column, which is minus 1 minus 1 0, I will get minus 1 plus 1, which is again 0. With the third column, which is minus 1 1 0, I'll get again minus 1 minus 1, it's minus 2. Okay, now multiplying now the second row, which is 1 minus 1 1 times 1 1 0, I'll get 1 minus 1, which is 0. Now multiplying by minus 1 0, it will be minus 1 plus 1, which is again 0. Then with the third is minus 1 1 and 0, so you will get minus 2, because that will be minus 1 plus 0. Now same story, the entire row here will be 0, because 0 times anything. Now what is a3? A cubed, sorry, a cubed, it will be a squared times a. So a squared we have 0 0 minus 2, 0 0 minus 2, 0 0 0 times a. A is 1 minus 1 minus 1, 1 minus 1 1, 0 0 0. We will get the first row will give me 0, the second row again 0, the third row by first column will be 0, and these will be 0, and second by second will give me 0, second by third will give me 0, and we get a cubed 0. So we will say, since a cubed is equal to 0, then the rest are 0, and this means a is nilpotent. Okay, since it's a is nilpotent, we can find what is e to the power 80, which we said e to the power 80, it will be I plus a times t plus a squared t squared over 2 factorial. Okay, a cubed t cubed over 3 factorial, and so on, but this is equal to 0, so we will find 1 0 0 0 1 0 0 0 1 a squared, uh, which we get it from here. A squared, we get its a squared, it was sorry, a first times t, which is 1 minus 1 minus 1, 1 minus 1 1, 0 0 0 times t. Then a squared, which we get 0 0 minus 2 and 0 0 minus 2, and the whole here is 0 times t squared over 2 factorial. We will end up with the first entry here 1 plus t, and the second entry here we have 0 minus t and 0, and the third entry here 0 minus t again. 2 with minus 2 will go, so it will be minus t squared minus t squared. Same thing, 0 plus t plus 0, and then we have 1 minus t and 0, and that will be 0 plus t minus t squared, and that will be 0, and the last one, it's here we have just 1. That is a nice question, and that's the end actually. Okay, that is all for section 8.2, I guess, exponential matrix and linear system.